Section 4.3, multiple angle equations. Let's go to the next slide. It says find all real numbers that satisfy each equation. Before we start looking at the actual equation, let's highlight the fact that in this problem there's no restrictions, and this will make more sense in just a little bit. So let's focus on the problem. So we have radical 3 tangent of 3x plus 1 equals 0. What we're going to have to do in this problem basically to solve for x. So in order to do that, I need to solve for tangent of 3x. Take away 1, divide both sides by radical 3. This is what I get. Rationalize, and this is what I have. Tangent of 3x equals negative radical 3 over 3. Now at this point, I need to find for what angle or angles tangent is equal to negative radical 3 over 3. And turns out to be 5 pi over 6 and every pi k units after that. So from here, what I need to do is I need to bring down the argument of 3x and place it on the left side of this equal sign. On the left side of the equal sign. And then my goal is to basically solve for x. I don't want the 3 there, so what I'm going to do is I'm going to multiply both sides by 1/3. Once I do that, this is what I get. I get x is equal to 5 pi over 18 plus pi over 3k, and again, k represents an integer. From here, this could be my answer, or I can express my answer using set notation the following way. Set of all x's such that x is equal to, you can follow. So we're done with number 1. And notice that we have an infinite amount of solutions to this problem. And the reason for that is related to what you saw in 4.2. If you were to consider graphing this function tangent of 3x and this other function y equals negative radical 3 over 3, you know that they're going to intersect an infinite amount of times. And this will be your solution. Here's number 2. Just like number 1, our goal is to solve for x in this equation. So I'm going to isolate cotangent of this argument, and I end up with cotangent of pi x over 4 equals 1. And at this point, you need to consider cotangent is equal to what? Cotangent of what angle is equal to 1? It turns out to be pi over 4 and pi k units after that. So then you bring down the argument. Then at this point, your goal is to solve for x. So you're going to multiply both sides by 4 over pi. On the right hand side as well, 4 over pi. And once you do that, you clean it up, and this is what you get. X is equal to 1 plus 4k, and k is an element of the integers. You can also express, just like number 1, set notation, and this will be your solution. Set of all x's such that x is equal to 1 plus 4k, k element of z. So from here, let's jump to number 3. It says negative sign 3 pi alpha plus 1 equals 0. Just like number 1 and 2, my goal is to solve for alpha. I'm going to solve for sine of 3 pi alpha. This is what I get. From here, sine of what angle gives me 1. It turns out to be pi over 2, and then 2 pi k units after that. Bring down the argument, which is 3 pi alpha. And from here, you want to get rid of the 3 pi, so multiply both sides by 1 over 3 pi. 1 over 3 pi. Once you do that, this is what you get. And you can also express set notation on this problem, but I didn't. Either one would be correct, either regular or set notation. So let's go on to the next slide. Here's number 4. says find all real numbers in the interval 0 to 360 that satisfy the equation. So here's a problem. Eventually we're going to have to solve for x. But before I do that, let's highlight a key part of this problem, which is we need to identify that we do have restrictions and answers have to be within this restriction here, 0 to 360, not including the right endpoint, 360 degrees. So to do that, just like number 1, 2, and 3, I'm going to solve for sine of 2x. This is what I get. And then at this point, I need to, it's going to be a little bit different than the other previous 3 problems. So what we need to do is sine of what angle gives me 1/2, and this happens at 2 locations, quadrant 1 and quadrant 2. So I'm going to bring down 2x, and then it happens sine is 1/2 at 30 degrees, and every 360 units after that. And then it also is sine of 150 is equal to 1/2, so that's why I have 2x equals 150 and 360k units after that. Now, at this point, just like the previous problems, my goal is to solve for x, so I don't want the 2 there, so I'm going to divide this equation by 2, this equation by 2 both sides, and this is what I get. Once I have this, I'm not done. What I need to do is I need to play with these 2 equations here, and I need to include k values that would generate answers that are between 0 and 360. That satisfy this restriction here, this interval. So here we go. This is what is different from the previous problems. So here I start playing with k values. First I start with k equals 0. When I plug in k equals 0 here, I end up with the following. I simplify and I get 15 degrees. So this is one answer. And then I go to the next one, and I also plug in 0, and that's what you see here, and I get 75. So 15 and 75 are part of these solutions to this problem. And notice that these 2 answers, 15 and 75 degrees, lie within this restriction here. So let's continue. Now the next k value that I'm going to use is k equals 1. So I substitute for 1 here. So for k, I substitute 1, and this is what I get. It gives me these 2 answers. And then from here, if I was to try k equals 2, I'm going to end up with values that are not going to be in this interval. So my answers to problem number 4 are what you see here. And I'm going to represent that using set notation. So this is the solution to number 4. Very different than the previous problems. Here you have a finite amount of solutions, unlike the other ones in which there is an infinite amount of solutions. Here's number 5. So my goal again is to solve for cosine of 6x. So once I do that, I end up with cosine of 6x equals 1. And then at this point, cosine of what angle gives me 1. And it turns out to be 360, so that's why I have 6x equals 360k. From here, I'm going to solve for x, which means I'm going to divide both sides by 6, and I end up with the following. And then this is going to help me generate all the solutions to this equation that fall within this restriction. So start plugging in k values, starting with 0. When k is equal to 0, I get 0 degrees as one of my answers. Continue, k equals 1, I get 60. You should be able to follow this. At this point, this will be the last one. K equals 5 generates the last answer. And if I try k equals 6, I am going to hit 360, and I cannot include 360 as my answer. So I represent all these answers using set notation. And here's my finite number of solutions to number 5. Let's go to number 6. This one will be done in class. Let's go to the next slide. So here's 7. The only thing that changes is that now that you have, instead of degrees, now you have radians. So we start out the same way as the previous 2 problems. So solve for cosine of 4 alpha. Again, no restriction. Notice that we have restrictions. So this is what I get. I can rationalize from here. You cosine of one angle gives me negative radical 2 over 2. It happens at two locations, quadrant 2 and quadrant 3. So here they are. At quadrant 2 is 3 pi over 4, and every 2 pi units after that, and also quadrant 3, 5 pi over 4, and every 2 pi k units after that, 2 pi units after that. And my goal is to solve for alpha, which means that I don't want the 4 in front here nor here. So I multiply by 1/4 both of these. The left and right side. I'm not going to do that here, but it's basically the same thing. And this is what you get. And then from here, this is where I want to start playing with my k values that generate answers that fall within the restriction here. But before I do that, since I have two fractions, I'm going to rewrite this second expression here, these two, with a denominator of 16, which means that I'm going to have to multiply top and bottom here by 8, top and bottom by 8, and this will be easier to work with. So then I start with k equals 0. Once I do that, I get these two solutions, 3 pi over 16 and 5 pi over 16. And then the next k value that is going to generate answers is k equals 1. So that once I do that, I get, notice that this becomes just 3 pi over 16 plus 8 pi over 16 times 1, which is basically 8 pi over 16, and it gives me 11 pi over 16. And you should be able to follow how once you plug in 1 here, you get 13 pi over 16. I continue. I try k equals 2, and I still have two angles that are less than 2 pi. So I continue. I try 3, k equals 3, and I still have these two angles, 27 pi over 16 and 29 pi over 16 are less than 2 pi. So it turns out that these are my, if I was to try to use k equals 4, I am going to end up with two answers that are not within the restriction here. They're going to be greater than 2 pi. So I express all these answers that you see here, and using set notation, and this is what I get. And notice that they're all in order. It would be, this is what you want to do. You want to rewrite them in order. So here's the answer to number 7, and again a finite number of solutions. And here the only difference is that now that the answers are in radians. Let's go to number 8. So isolate sine of 3x. This is what I get, radical 3 over 2. So what angle do you have radical 3 over 2? It turns out to be at two places, quadrant 1 and quadrant 2. So here they are at pi over 3 and every 2 pi units after that, and also 2 pi over 3 and every 2 pi units after that. Quadrant 1, quadrant 2. So from here, I don't want the 3 in front of the x on both of these expressions here, so I multiply both sides by 1/3. Same thing on the other side here, 1/3. Once I do that, this is what I get. And again, I didn't do it on this side, but this is what you get. And I'm going to start to plug in, I need to plug in k values. And notice that I do not have the same denominators, just like number 7. I'm going to rewrite this 3 as a denominator, this denominator of 3 as 9, so I multiply top and bottom by 3. Same thing here. That's what I get. Start plugging in k values until I start plugging in k values, and I need to stop once I get answers that are past this restriction, that do not satisfy this restriction. And it turns out to be that you plug in k values of 0, 1, and 2, and they generate all these answers. And here's number 8, the answer to number 8, or answers to number 8. Again, a finite number. Let's go to the last slide. 9 and 10, and these two will be done in class. This concludes the video.